Question 3 asks about another experiment, this time to do with 3 different woodpeckers and the amount of time that it takes for them to descend a metal rod. So it gives you all this information about the practical and then gives you some results. So the independent variable is the mass, the dependent variable is the time taken for the woodpecker to descend the metal rod. First question says, draw a circle around this anomalous measurement. So an anomaly is anything that doesn't fit in with the pattern. So these 3 results for C are all quite similar. For B, one particularly stands out, which is the result for test 1, which is 3.1. That's the most different. If you check the ones for A, again, reasonably similar. You might think 11.8 is quite different, but it's not as different as the 3.1 to the 5.4 and 5.5. So you would draw a circle around B. State the relationship between average speed, distance moved and time taken. Average speed, you don't need to write the average, but speed equals distance divided by time. If you are going to use symbols, be very careful, because for this equation they're a little bit strange. So speed is v, distance is s, and time is t. So with any question like this where it asks you to write down an equation, we recommend that you use words. So then it wants you to calculate the average or mean speed for woodpecker B. So you have to ignore the anomaly now. So you take the average of 5.4 and 5.5. So 5.4 plus 5.5 divided by 2. So you end up with 5.45 seconds. And then you use that number in the equation above, and again show all your working. I'm writing very big here, so that's difficult for me to do, but you should show all your working out. The distance you get from the information up here, and the distance is 20 centimetres. Now the answer, it wants it in centimetres per second. So for some questions, you might need to change the distance into metres. For this question, it does not want you to do that. So always check the unit that it wants, just to make sure that your answer matches the unit. So in this question, it's going to be 20 centimetres divided by 5.45 seconds, and then that should give you an answer of 3.7 centimetres per second. Now, explain what type of graph the student should use to present his data. There is no right answer here. You can choose either a bar graph, a bar chart, or you could choose a line graph, scattergram, that kind of thing. So a bar chart, you could justify choosing a bar chart because the woodpecker is A, B or C, and that is a discrete variable. So the woodpecker, if you put woodpecker on the bottom here, blah, 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 with A, B, C, then that would be a bar chart because it is a discrete variable. It's not a number, it's just a label. If, however, you put mass on the bottom of your graph, then you would need to plot something like that with crosses. That could be a line graph, or sometimes it's described as a scattergram. And that's because mass is a continuous variable. It can have any value. So it doesn't matter which of those ways of representing the data you choose, the marks are for justifying your choice. Okay, so now you've got to discuss the results. So again, no right or wrong answer here, they just want your ideas. So you need to basically decide whether it supports the prediction or not. You can do plus or minus suggestions. Now for these results, if these were real, you wouldn't particularly trust them. So as the mass increases, the time, well, first of all, the longest time is for the highest mass. But then for the next highest mass, the times go down quite a lot and then they go back up again. So there really isn't any kind of pattern there at all. You can discuss all of those results. You'll get marks for mentioning particular values as well. So my answer would be no, it doesn't support it for those reasons. As the mass goes down, the time first goes down but then goes back up again. You will also get marks for saying why the results are insufficient. So for any kind of experiment, 3 different values for the independent variable would not be enough. You need a minimum of 5 values for the independent variable. So you would need to extend the range of the results if you actually wanted to get data that would support the prediction.